Welcome to the NXP EdgeVerse TechCast, the podcast where we explore the software, tools, and enablement helping developers bring edge innovation to life. I'm Bridget Stone, one half of your hosting team.
And I'm Kyle Dando. I'm the other half, and depending on the day, I'm either the stronger half or at least the louder half.
Haha, very funny, Kyle, but also true. And I'm glad you're here with us today. And today's episode is all about going long range, literally. We're going to cover sub-GHz wireless connectivity and a new set of projects now available on the NXP Application Code Hub to help developers evaluate and integrate NXP's UBX100 transceiver.
And we're joined by someone who's deeply involved in making this technology accessible to all our developers. Tony Trujillo, he's the systems engineer at NXP. Tony, welcome to the EdgeVerse TechCast. How are you doing?
I'm doing very good, thank you. I'm very happy to have the opportunity to be here with you today and looking forward to our conversation.
All right, before we jump in, why don't you take a little bit of time to introduce yourself and share your role and how you found your way into wireless connectivity?
Yeah, for sure. Good day, everyone. As Kyle mentioned, I'm Tony. I've been working at NXP in Hamburg for the past 3.5 years, which is also about the same time that I've been living in Germany. I am originally from Mexico, but about 9 years ago, I had the chance to come over to Europe through a scholarship to do a master's degree. And there I met amazing people and also had the chance to live in different countries and work in some of them as well. For example, Hungary and today, Germany. I really enjoy the semiconductor industry. Since I was in Mexico, this is the area that I've been working on. When you don't find me in the office, then I tend to be outside in nature with my girlfriend, especially doing hiking, which is quite accessible over here in Germany. And if the weather is good, like in spring and summer, we take the SUPs out, we go to the lakes and rivers for a ride, and take the grill as well to do some Mexican barbecue. On the more personal side, I really enjoy photography and cooking, especially baking. And I'm trying to get a little bit into the coffee world as well.
Well, that sounds like a lot of fun, Tony. Load up on quality caffeine, then you push off on a stand-up paddleboard, and to top it all off, you pull out the barbecue. It almost sounds like you're living here close to me in Austin, Texas.
I'm getting hungry right now just talking about this. But anywho, Tony, thank you for being here. We love starting with a big picture question. Imagine you're introducing sub-GHz wireless to a classroom full of students, and your mission is to keep everybody awake. How would you explain sub-GHz in a simple, relatable way?
As you know, in our world, pretty much everything is interconnected. Devices are talking with each other, they're sharing information, and most often than not, they're also connected to the internet. While this can happen through wires, meaning the devices are physically connected, most of the time this is wireless. We have no cables, we only have radio devices that are sending and receiving data at different frequencies. I would say that when people think wireless, most of us think about Wi-Fi and Bluetooth. This is what we call 2.4 gigahertz technologies. Allegedly, Wi-Fi also works at 5 gigahertz, but I digress. 2.4 means the frequency at which the devices are operating. We have many consumer devices working in this frequency, like phones, your headphones, laptops, smartwatches, you name it. But this is only one part of it. Of course, we have a lot of other frequencies below, hence the name sub-GHz or below 1 gigahertz. Here we also have a lot of devices, but maybe we just don't think too much about them. For example, your garage door opener, that is sub-GHz. Your car key to unlock the car and the detection proximity, also sub-GHz. Many alarm systems in homes or smart meters at homes, they tend to be sub-GHz as well. When you go to the supermarket, these fancy shelf labels, they tend to be sub-GHz as well. Or when you do contactless payment or this anti-theft tags in the clothing or in some products, also sub-GHz. Even the phone, right? Still, there are many frequency bands that are below 1 gigahertz. This technology is also very common in our day-to-day life. In general, this is chosen over higher frequencies for 3 main reasons. One of them being distance. This tends to be used for long-range communication purposes. Signal penetration, which can give better performance, especially in inbuilt areas, for example, when you have a lot of concrete around you. And also energy consumption, which makes sub-GHz applications suitable for battery-powered solutions. Also, there's the interference factor. Since 2.4 gigahertz is so popular, a lot of devices tend to be there. Sub-GHz gives you some chances to reduce this interference issue.
Excellent examples, Tony. Garage doors, key fobs, smart meters, these are all technologies people use every day without realizing sub-gigahertz is behind them. Would it be fair to summarize sub-gigahertz as the choice when you need longer range, better penetration, and efficient power usage?
Yeah, absolutely. This is really the domain where our UBX100 transmitter fits. We're trying to enable long range, low power sub-gigahertz connectivity together with our large portfolio of microcontrollers with a focus on metering through technologies like wireless M-Bus, but also other solutions with technologies like Sigfox.
All right, well, now let's jump right into the application code hub. That's something I really like to talk about. Your team contributed this latest project to the growing list of applications in the application code hub. However, I was particularly excited to see these examples because, as you just brought up, they address sub-gigahertz or the ISM band for wireless applications. So explain to the listeners those different projects, because some of our listeners may not be aware that you guys added them recently.
Yeah, for sure. Our team was trying to think of different tools that someone that wants to develop with UBX100 would need. We're trying to enable development, but also allow people to perform quick out-of-the-box evaluation and provide templates that can be used to build more complex solutions. I would also add that for UBX100, we have two paths. We have the radio-modem-path for standard radio configuration applications like wireless M-Bus, and we have the Sigfox modem path. What I'm going to mention now is what you find in the application code hub today, which is the radio modem path, and the rest will be enabling very soon. Today we have 4 solutions. First one is the UBX100 SDK. This one has the binary image that go into the UBX100, as well as the driver that is used in the host microcontroller to interface with the UBX100. This one we call Host Radio Modem Library. It allows you to configure and control the radio, and it'll be at the core of every microcontroller application that will be interacting with the UBX100. The SDK, of course, also has documentation, and I would say this is a starting point for everyone developing with the UBX100. Then we have the UBX100 flash loader demo. Our UBX100 has a flash loader and a bootloader in memory that allows to provide a new image to the device, effectively reprogramming it. This example shows you how to do just that with a microcontroller, specifically the MCX N947 Freedom board. This is a key step for everyone during development because the UBX100 comes unprogrammed, and this application would be your starting point to achieve this first task.
Tony, that's perfect. That's just what the application code hub is for. Those first 2 projects, a person has interest in the UBX100, they can go in, take advantage of those 2, evaluate the product. But now what are the other projects enabling? I'm assuming those would go a little bit deeper into the features and some configuration options of the devices?
Yeah, definitely. So we already commissioned the device. It's programmed. Now we want to use it. We have for this the UBX100 RF Toolbox, which focuses on showcasing the functions of the Host Radio Modem Library in the context of RF lab testing and also certification, which everyone developing a solution will need to go through at some step. Lastly, we also have the UBX100 FreeMASTER Evaluation GUI, which we intended to be the out-of-box evaluation project. This one comes with the application that goes into the host microcontroller, and it also comes with a graphic user interface that is web-based, and that would allow you to do quite a few evaluation tests.
I was so excited when I saw FreeMASTER included in this project. We covered it in previous episodes as a powerful visualization tool for embedded developers. But here it's being used not just to observe, but to interact. Can you explain how FreeMASTER Light helps developers configure and evaluate UBX100 in real time?
Yeah, for sure. As you just mentioned, FreeMASTER is mainly used for data visualization, and it is great for it. But this tool also comes with a sub-product called FreeMASTER Light, which is what we ended up using. This one also provides data visualization elements, but it gives you some more customization options on the graphic user interface side. For FreeMASTER, in the application for the computer itself, you would develop the GUI, and FreeMASTER Lite allows you to connect a custom GUI to it. for example, a web-based graphic user interface, which means it would display as a website in your computer, and it would even allow you to do remote mobile access, for example. Since we wanted to provide control and configuration of the UBX100 through our application beyond just showing data, this flexibility on the GUI made FreeMASTER Lite the ideal solution. This FreeMASTER GUI example is very good for out-of-the-box evaluation. You would basically take two UBX100 development kits. That means two FRDM MCX N947 boards and two OM UBX100 boards. You would install FreeMASTER Light in your computer, download our example from the application code hub, program the FRDM boards, launch the GUI, and you're ready for evaluation.
That's incredibly powerful, especially being able to control and evaluate the radio through a browser-based GUI. Now, would you say this dramatically lowers the barrier for developers who may not have that deep expertise yet?
Yeah, absolutely. This was really the intention, to make evaluation very easy. The GUI will have some tabs, each one with very specific purposes. First, one to configure the radio and to select the mode of communication that you want to use, and then different tabs for testing. One tab to perform simple transmit and receive, where you can really see visually what is the data that you're sending and how does the data look like once it's received. We also have a tab for range testing, which can be quite useful, especially to evaluate the range that you have between two devices, as it can report things like packet error rates. We also added a simplified wireless M-bus sniffer to the tool.
That sounds like a great use case for FreeMASTER, and your team did a great job utilizing it. It does provide direct access to the device under test, and it helps those users go in and try out the different parameters in a much more organized manner. With sub-GHz, there's so much custom capabilities, and when the user gets it, they're really going to want to dive into the benefits of the UBX100 and the SDK that you said comes with it. So what are you and the UBX software team most proud of? And what do you find most of the customers, when they evaluate it, they say this is a great solution from NXP?
I agree with you, Kyle. I think that you hit the point here. Radio transceivers can be tricky, right? Especially on the configuration side. When you're trying to tinker with the settings and registers, this can be a quite complex task, even when the tools are provided to do this. But with the UBX100, we decided to take a more simplified route with very specific applications in mind, especially on the metering side. The UBX100 allows you to choose from a preset of standard radio settings that will comply with the requirements of very specific protocols. In our case, that would be wireless M-bus, mode S, C, and T, and also several WISON modes. This settings is what is also known as radio PHY configurations. While we provide some flexibility to change parameters like the transmit and receive frequency, other parameters are fixed, again, to fit the requirements of these standard specifications. I mentioned it previously, the UBX100 has a flash loader and bootloader that allows for on-the-field firmware upgrades, which is quite good to update the image whenever NXP provides a new version with bug fixes, for example.
All right, well, it's great that you support wireless M-bus and WISON, extremely popular with the metering in the sub-GHz community. But what are some other ways that developers can use the wireless sub-GHz in their own custom devices and to meet their own needs?
Yeah, when we're talking about a custom device, usually a full solution will also require a wireless stack that will be running in the host microcontroller. For this, we have partnered with Stackforce, which today offers a wireless M-bus stack that customers can use directly. Of course, customers can develop their own custom stack solution, or they can create their own custom protocols, just as long as they are using one of these standard PHY settings that I mentioned before. We also have two development paths for the UBX100. What I just mentioned here corresponds to the first path, the one called radio modem. The second path will be added to the application code hub very soon. Overall, once you update the UBX100 with the appropriate image that will come with the SDK for this second path, the UBX100 now will operate as a Sigfox end-device modem. In this scenario, the host microcontroller no longer will need a wireless stack because this is already included in the image that you're putting in the UBX100. Of course, a host MCU is still required, and you will need a driver to communicate with the UBX100, but all of that will be provided in our SDK package for this path. But I would like to highlight that the physical connection between the host microcontroller and the UBX100 will remain the same no matter which path you're choosing. So you really can leverage both solutions.
This is exciting, Tony. We've had guests in the past cover Bluetooth, Wi-Fi, and other 15.4 wireless applications. You've really helped me and the listeners understand NXP's offering for another very popular way of wireless connectivity. Even though the episode is centered on the application code hub, which is the obvious place we encourage listeners to visit to get started, what are some other resources that customers can benefit from or maybe sometimes get overlooked?
Yeah, I would really recommend customers also look at the expansion board hub. There they can find a large selection of NXP and third-party expansion boards that are compatible with the MCU ecosystem from NXP, including our UBX100 radio board. They will also find links and documentation here to get started with the hardware and software. I would also encourage customers that want to develop a wireless MBUS solution to get in touch with our partner StackForce to gain access to an evaluation version of their wireless MBUS stack and get their development started.
That's a great reminder. Between the expansion board hub, partner stacks, and product documentation, developers really have a full ecosystem to support them.
Yeah, definitely. When it comes to the Sigfox path that I was talking before, looking at resources from the Sigfox build website is a very good place to start familiarizing yourself with the protocol. Of course, always keep an eye out to the application code hub. This support package will come live very, very soon. We're also planning to keep adding new examples to keep enabling our customers. Lastly, check the UBX100 product page in nxp.com. Here you will find the datasheet of the device and also reference designs from NXP that use the UBX100 as the wireless sub-GHz connectivity block.
Terrific job, Tony. This conversation and this episode has identified some great features and benefits for our listeners to investigate further. Before this episode, I had a lot of questions about NXP's offering in the sub-GHz space. The details you provided and with the application code hub examples, I think I can quickly ramp up and better understand what NXP has to offer.
Absolutely. And I especially love the combination of ready-to-use code, visualization tools like FreeMASTER Light, and flexible modem paths gives developers both power and simplicity. You've provided a lot of great information today. Kyle and I will make sure to put the resources you mentioned in the episode notes. Thanks for joining us, Tony.
Yeah, absolutely. Thank you as well. I really enjoyed having a chat with you and, of course, having the chance to talk with our audience and give them a little bit of taste about the UBX100. So thanks again for having me.
Oh, no problem, Tony. Thanks for joining. And for our listeners, if you enjoyed this episode, don't forget to like, subscribe, and turn on your notification. Make sure you tell a couple friends. We're always happy to have more people join. And if you want more details on the topic of UBX100 or ISM wireless solutions, let us know in the comments below.
And until next time, keep innovating, jump off the gigahertz airwaves, and try some sub-gig, and we'll catch you on the next EdgeVerse TechCast.